All right, hello. The first question I'm going to go over is question number 1. So let's take a look at what our clues are in the problem. So it says, a beta blocker medication is tested with to treat high blood pressure. Subjects with high blood pressure volunteered to take part in the experiment. 170 subjects would receive a placebo, and 250 subjects received the medicine. High blood pressure disappeared in 90 of the controls and in 142 of the treatment group. Test the claim that the new beta blocker medicine is effective with a significance of 0.10. All right, so what are the things that we know? Well, we know that they did not give us any standard deviations. There's no population standard deviations. And if you see no standard deviations, then we're not talking about averages. We're actually talking about counts here, right? So we are talking about whether the percentage of people in the control was less than, equal to, or greater than the percentage of people who improved in the treatment. And in this case, what we're saying is that the percentage of the treatment in the control is equal to the percentage of the treatment in the treatment group. So this might be P1 and P2 here. And then what we'd really like to see is that the treatment group there is significantly greater. That means that that would be our claim, and that would mean that the medicine worked, right? So we're going to find our test statistic here, and there's a couple ways we can do this. We can use the formula of like P1 minus P2 all over the square root of P1 minus P2 divided by our total sample size. Hang on a minute, I think I am messing this formula up. 1 second. Sorry about that. It should be P hat Q hat times 1 over N1 plus 1 over N2. All right, so let's go over what these are. All right, so P1 is the control group, and 170 total. And that proportion would be that was successful in the control group would be 90 over 170. P2 is the control or the treatment group at 250 total, and that proportion is 142. And then P hat is the total out of the total, right? So the total successes, so 170 plus 250, 420, and total successes 90 plus 142, and then Q hat is 1 minus P hat. So that would be, so these are the numbers that we could plug in to find the test statistic. And I will show you how to do that just by hand, but also you can do this all using your calculator, and I'll just walk you through the steps on that as well. So if I go ahead and do this now, I've got a 90 minus 170, or over this, just plugging the numbers in. And when I plug that in, I get the following. Make sure if you do this on your calculator, typing it in like this, that you use parentheses in the appropriate places so you don't have an order of operation error. Which is a pretty common thing to have happen. Another thing is you might consider converting these all to decimals to make sure that you don't get an order of operation error. So from here, I end up with negative 0.7806405558. And this is called a two-prop z-test because it's using a normal approximation to the binomial distribution. So we're using a normal curve here, standard normal with a mean of 0 and a standard deviation of 1. If our test statistic is negative, so if this is 1, standard deviation away from the mean, our test statistic is negative 0.78. So we're looking for the area under the curve of here. That area is our p-value, right? So if I want to find our p-value given this test statistic, that p-value is the area under the curve from the test statistic to the most extreme, like to the closest tail. So, and this is a one-tailed test and it's a left-tailed test, so that makes total sense. So I'm going to go now to find this area. I'm going to go normal CDF on the calculator. And second distribution. Number 2 is normal CDF. So again, that's in the distribution. Looking for the area from negative infinity. So negative 1 times e to the 99th up to negative 0.780640558. Mean is 0, standard deviation is 1. I hit paste and enter. And my answer here for my p-value is 0.2175, which is not less than alpha, so I do not reject. And there's not significant enough evidence to suggest that the differences are just not enough to suggest that the treatment was better than the control group. So hopefully that will answer your question on how to find p-values given a test statistic. All right, moving on. I was messing that up a bit. Oh, what happened to it? Here we go to the next one. All right, so this one, a teacher would like to determine if the quiz improves after completion of a worksheet. The students were given a pre-quiz, then the worksheet, and a quiz after the worksheet, and assume the quiz scores are normally distributed. The grades for each quiz are shown below. I have an alpha 0.05, excuse me, and we're doing a matched pair test. It tells you this, but we would know it was matched pair test because these are, each line represents one student, and so it's dependent samples. And it also tells us that they want the difference to be less than 0. So, you have to be thoughtful about how you set that up. It says pre-test minus it's pre-test minus post-test. So if they went down, like if you had, she would like to improve their scores. So if I did post-test minus pre-test, these would all be greater than 0 because it went up. If I do pre-test minus post-test, like it suggests here, then it would be less than 0 because these all went up and this is down. So that's the idea, and that's what our claim is. It's just, you need to like give some thought to how you're doing this. So if I do this, pre-test minus post-test, it's 2, and then this, negative 18 minus 16 is a positive 2. 11 minus 14 is a negative 3. Negative 6. Negative 4. Negative 2. Negative 4. Negative 2. Negative 1. Negative 3. 1. Positive 1. Negative 3. Negative 10. Negative 5. Negative 2. Negative 3. Negative 5. Negative 7. Negative 1. Negative 6. And negative 8. So, sorry, by hand. You certainly wouldn't need to. You could enter, okay, if I were doing this for real, like not on a video where I had limited technology, I would just copy and paste this into Excel. And then I would say this would be A1, this would be A, this would be B, and in C, in C1, I would put the formula, just A1 minus B1, and then I'd fill down. That would give me all of these. And then once you have all of those, you want a one sample t-test. On those differences. In Excel, actually, if you have the data analysis tool pack, then they have a matched pair t-test, and you can just run the matched pair. Similar as well in Minitab. But since I'm working on the calculator, I can just do this in my head and then enter in this list. Or I can enter this whole list in L1 and this whole list in L2. And then L3, I go to the very top of my calculator list and I just type in L1 minus L2 and it will calculate the differences. So those are my choices on how to do that. We're going to go ahead and edit my lists here, and I'm going to go ahead and type that list in. So I'm going to go ahead and do that, and just to make sure I didn't make any silly mistakes on my arithmetic, which is known to happen. I'll go ahead and type in the whole list. 13, 13, 20, 13, 13, 12. When you're doing that this way and typing the entire list in, it's really important that you have everything matched appropriately with the right person, right? You don't want to get off track on one and then have it be not the right one, right? Not the right pair. So you're like, look, and make sure that 13 is going with 19, that 12 is going with 16, and so on. It doesn't matter so much if you switch a pair in order, but it does matter if the pairs are unswitched. So we got that. Six, 11, 3, 10, 15 goes with 16, 8 goes with 14. And 8 goes with 16. All right, so now I go to the very top of L3, hit enter, and then I just type L1 minus L2, and this generates my whole list. And now I can go to stats, over to tests, a one sample t-test, number 2. I have data, not statistics. It says, what do you expect the mean to be? I expect it to be 0. That would mean that there was no change at all. My list is in L3 now, and it is a left-tailed test. So I select that option and I hit calculate. And that gives me the following test statistic. negative 5.5000005, and the following p-value 0.000013. Now, notice that the p-value is actually reported on my calculator like this, and I see this a lot on exams. Right? Obviously, it can't be more than 100%. P-value is a probability, and it cannot be greater than 1. It has this e to the negative 5 after it, and that means that this decimal place is moved over 5 places. Okay? The correct is to reject, obviously, with such a small p-value. The summary would be say that the evidence suggests that the worksheet did improve scores. Right? So it did, yes. The worksheet did improve scores. So that is how to do this problem. I did all those. We have another before and after, and whenever you have a before and after, again, it is going to be a match pair t-test. This would be the exact same process as before. I'll just run through this one really quick. Okay, so I put this into L1 already, and that into L2. I made an L3 that was after minus before, so it's L1 minus L2, right? And where it's a two-tailed test this time. So the first thing they ask for a critical value, not a test statistic, a critical value. Think about what's going on here. This is 0, this is a t-test. Okay. So we're going to go from there. We have degrees of freedom, 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 subjects. N minus 1, so 16. Our degrees of freedom is 16. So I want to find that. I'm going to go to inverse t on my calculator. So second distribution, inverse t. Area, alpha is 0.00 into 2 tails. So I have 0.05 here and 0.05 up here. So I put 0.05 for my area, degrees of freedom is 16, and hit paste. And I get negative 1.746. Okay. So that's the number that's going to go here, not the negative. You can just put because it already has a plus and minus here. And this is a symmetrical curve. So that helps us there. So this is our critical value to 4 decimal places. I'm sorry, it's actually 1.745883. So 4 decimal places would be here, so it'd be 1.7459. All right. And it says drag the arrows to adjust the value, so we would move this little bar up here to say both, like to have it will split, and you'll move this one down to 1.7 and this one up to 1.745. Right. And then what is the test statistic for this sample? The test statistic for this, after I ran my one sample, I went tests, number 2, one sample t-test, and then I put in data. Mu is 0 because we're expecting no change, and I put L3, and I put not equal, and I get, when I do that, I end up with 1.07917. All right, and so that would be up here, but not all the way up here. So the test statistic is not in the critical region. So this is do not reject. And we would say that there is no difference. The evidence does not suggest a difference between scores. All right. Hope that's helpful, and have a great day.